I want to talk today about paradigms, but it's one of the concepts that you'll come across in discussions of methodology. It's one of the most widely used words in the social sciences since the word was introduced in the 1970s, but it's also very widely misunderstood. So paradigm, the idea comes from a book by Thomas Kuhn, and the book was called The Structure of Scientific Revolutions. And in that book, Thomas Kuhn introduced the idea of paradigms. But I don't want to start there. I want to give you a bit of context in which to place the idea of paradigms. I think probably have to start in the 17th century. And in the 17th century, Isaac Newton put forward a view of the world, a view of the universe as controlled and governed by strict laws, the laws, universal laws of gravitation. And he produced a theory that was so successful that for the next 250 years, the most important question of philosophy was, how did he get it right? How did he manage, from the few observations, relatively speaking, from the possible infinite number of observations of stars and planets and galaxies, how from the small sample that astronomers had made up to that point, how did Newton manage to get a universal law of gravitation? And then at the beginning of the 20th century, Einstein put forward the theory of relativity. It wasn't exactly a sudden transition from Newton's physics based on Euclidean geometry to Einstein's relativity based on non-Euclidean geometry. There'd been some, well, we'll come back to that. During the 19th century, there'd been some development. But at that moment, the question shifted from being, how did Newton get it so right, to how did Newton get it so wrong? And if you look at I think the pre-19th century philosophy, my hero, of course, is Immanuel Kant. And Kant had offered an explanation of Newtonian physics that had explained how it was possible for him to have got a universal law from the observations that were made, talking about the nature of space and time, explaining how Newton's idea of space and time was built into the way that people think. Einstein, coming with the idea of relativity, overthrew that view and immediately, in response to that difficulty, I think the key philosopher of the new relativity was Popper, Karl Popper, who suggested or drew attention to the fact that it only takes one mistake, only one error to prove a theory wrong, but many, many examples of the theory being right don't prove it's true, but a single instance of a refutation will overthrow the old theory. So Popper's argument was, well, Newton's theory had been used for 250 years. People had been looking for cases where Newton was useful, but in fact, when Einstein put forward his theory of relativity was because one example had shown that Newton was wrong. Or the one example being ostensibly the measurements of the passage of light around the sun during a solar eclipse in the early part of the 20th century. Now, there are problems with that account, and the problems with that account are primarily that the idea is that Popper puts forward is that you could have a distinctive critical experiment that explained the difference between, that decided the difference between Newton and Einstein. Strictly speaking, it's the idea Newton suggested that light would not be bent by gravity. Einstein suggested that light would be bent by gravity, and therefore observing the position of distant stars close to the sun when during an eclipse would be the critical test that would test between those two theories. Now, it doesn't quite wash out like that, because once you'd got relativity, once you'd got the idea of relativity, certain things which had been observed hundreds of years ago started to fall into place as instances when Newton's science wasn't working. For example, the path of a planet around the sun is something like this shape. The sun is at the focus of an ellipse, and the elliptical path is the path of the planet. And in theory, according to Newton, Mercury or Venus, the planets close to the sun, would go around tracing exactly the same path every time. Every time they would trace exactly the same path. That isn't what happens. This distance, the perihelion, actually moves so that the path of the planet goes something like that, and the orbit of the planet rotates. Now, once relativity had been suggested, that actually explains the precession of the perihelion. It explains why the planet doesn't follow exactly the same path every time that it goes around the sun. But it wasn't realised that that was a distinction, that was something that was wrong with Newton until the relativity was put forward. It was thought to be just one of those strange things that we couldn't quite explain, but it wasn't realised that it was actually a refutation for Newton's theory. So it's not quite as simple as saying one experiment refutes the theory and therefore we move on to the new theory. So Thomas Kuhn came up with his idea of a paradigm in order to explain what's going on. There's something that happens. Newton proposes his theory. There's then a gradual collection of these, what Kuhn calls anomalies. These anomalies build up until suddenly, at some point, they burst and there's a new theory put forward. So Kuhn suggests that there are periods of what he calls normal science, and during normal science, the job is to apply the existing science to as many cases as possible. In the process of doing that, small anomalies will build up, and eventually the old theory will be thrown out and be replaced by a new theory that takes those anomalies and incorporates them into a new theory. So according to Kuhn, progress in science, these revolutions in science, are not driven by scientific knowledge. Kant had tried to explain Newton in terms of Newton's own science. Popper had tried to explain why relativity replaced Newton in terms of scientific knowledge. But Kuhn is saying, actually, there's something else going on. It's either the sociology of how many physicists believe Newton and how many physicists believe relativity, or it's something about how strongly people believe Newton or how strongly people believe relativity. So Kuhn is suggesting that science, progress in science, is not just about scientific knowledge, it's got something to do with the sociology or psychology of scientists. And that's extremely important to understand, that what's lost when you move into this world of paradigms is a sense of truth, a sense of objective knowledge, a sense of there is something that science is offering that's absolutely peculiarly scientific. More than that, Kuhn said, well, you can't easily compare Newton's work and Einstein's work. If your head is in Newtonian physics, you see everything in terms of Newtonian physics. If your head is in relativity physics, you see everything in terms of relativity. The Newtonian physicists will interpret what happens in relativity in classical terms. The relativity physicist will interpret everything that happens in Newtonian physics in relativity terms, and they can't talk to each other, they talk past each other, and that's actually, there is something like that going on. Towards the end of the 19th century, the anomalies that were building up in terms of the speed of measurement of the speed of light was interpreted by Fitzgerald Lorentz in classical terms, trying to explain the difficulties that were arising in the laboratory, in physics laboratories in the 19th century, to try and understand those in classical terms. Einstein turned things on their head and said, no, we're going to understand those anomalies in terms of relativity, and in terms of relativity we can then understand everything in Newtonian physics afresh. So there's a relationship between the two theories, but it's kind of tenuous. But Kuhn actually didn't say that. Kuhn said they are what he called incommensurable. You cannot, if you're a Newtonian physicist, you cannot talk to a relativity physicist. You see the world in those, if you've got pink glasses on, the world looks to you pink. If you've got green glasses on, the world looks to you green. And there's no point in talking to the person who is seeing the world differently. They just see it differently. They can't talk to each other. So the word paradigm, although Kuhn retracted this extreme version, but in his extreme version, the person who is in one paradigm cannot talk to somebody who's in a different paradigm. Somebody who is in one framework cannot talk to somebody who is in a different framework. And physicists are particularly bad at telling their own history. The physicists tell the history of their subject in a way that is designed to emphasize the logic of what they believe, to emphasize the progress and forward movement of science, and to minimize the idea that there are reasonable competing ideas, that it's actually difficult to move from one paradigm to another, or to one theoretical framework to another theoretical framework. So in his extreme version, Kuhn is saying, well, these people just can't talk to each other. If you've got your head in Newtonian physics, that's it. You're a Newtonian physicist. If you've got your head in relativity, that's it. You're a relativity physicist. And he actually says that what happens is that young people get inducted into the new theory and the old scientists die out. The people who believed in the old scheme retire or die, or their theory is lost. It's, in Kuhn's terms, in its most extreme version, there's no serious experimental difference. These are fashions that are happening. Well, certainly there are fashions that happen in science. I think that we know that medical science has changed. When I was very small, the cure for a nosebleed was to make somebody put their head backwards so that the blood would not run down the nose. Subsequently, first aid changed so that you pinch the nose, the person, and put their head forward so that the blood clots. There are fashions in science, but they don't explain everything. It's not just a whim that Einstein and Newton are different, or that you should choose one rather than the other. There are reasons, there are relationships between the Newtonian physics and relativity. So, for example, a relativity scientist will say that Newton's work remains as a special case within relativity. I'm not sure that's quite an accurate description of it, but there's not a complete break where Einstein goes off and says, I'm going to invent a new way of looking at the world. It builds upon the anomalies that have emerged from Newton's work. So there are reasons for choosing one paradigm over another. But in the social sciences, where the paradigms have become particularly widely referred to, perhaps even more widely than in the physical sciences, paradigms are seen to be a question of choice. If you are looking at the psychology of a situation, you will see one set of events. If you're looking at the sociology of a situation, you'll see a different set of events. And the idea that prevails, I think, wrongly in the social sciences, is that paradigms are simply a matter of whim. And in that line, it's possible to say there's a paradigm of Western science. All of this is Western science, or if you want to include Western medicine, virology, viruses, vaccines, anything that comes from Western science, that's a paradigm. And there is an alternative paradigm, which is somewhere else. Instead of looking at astronomy, we might just as well, we could on a whim see the world through the eyes of astrology. Instead of seeing modern Western science, we could look at the world through the eyes of traditional Chinese medicine. We could look, instead of Western paradigms of medicine and health, that the paradigms are simply you can see Western paradigms of science are imposed on the world because of the power of the countries. This is Marx's idea, is it not? The ruling ideas are the ideas of the ruling people. It's an arbitrary choice, an arbitrary decision to choose one paradigm rather than another. Choose, and in particular, I want to say choose indigenous knowledge is in competition with Western universal science, and that there is no good reason for choosing between one rather than the other. I want to say that's actually not what Kuhn said. It's not what Kuhn said in the Structure of Scientific Revolutions. He subsequently withdrew the most extreme arguments for that he had put forward for incommensurability. The idea is he wants to convey is that there is at least some sociological reason why the build-up of the anomalies doesn't automatically produce a change in theories, but it's not a question of anything will do. You can buy into any paradigm that you choose. And I think that this question of choosing a paradigm, it has become so prominent in the social sciences and it misses the underlying difficulty that there is, first in what Kuhn says, and second in whether Kuhn's work actually accurately describes the shift between one set of scientific theories and another. So really what I'm saying here is you need to be much more careful in addressing the question of paradigms. You need to understand there is a context to the development of the theory in the first place, that Kuhn himself did not wish to overthrow completely the idea of scientific tests and objective reality, but that has been the way it has been interpreted. And if you want to, and there is a large literature on this, if you want to see the person who I've found who most strongly opposes the concept of paradigms, then also almost certainly Michael Matthews will be the person whose work you might want to look at. But what I'm saying, I think here is clearly that it's more complicated than simply you can choose between one paradigm rather than another. The sense of the extreme case produces an idea of absolute relativism. You can choose the framework through which you look at the world. You can choose the concepts with which you describe the world at will. You're free to choose whatever you like in terms of your paradigm. I'm arguing that it's more complicated than that, and if you're going to try and understand what a paradigm is, it's not absolute relativism. There is something in between, and it's difficult to establish, but I think we need to have a look at this. There's something between the objective knowledge that Popper is putting forward and the relativism that Kuhn seems to be advocating, although he did subsequently deny it. I think we may have to come back to this because the idea of paradigms underpins some concepts particularly relevant in education around the idea of constructivism. And so I think I'm going to have to come back in another video and look at the idea of constructivism and unpack some of that.